Okay, here is the next example. Here also we're finding the energy stored in the inductor and capacitor. We know that this is a DC circuit. How do we know this is DC? Because of the source. Okay, source has only magnitude and there is no sinusoidal waveform in the source. If it is AC, as I mentioned in the previous example, it's going to be something like this, 45 at an angle of 0. Okay, it has AC is going to have magnitude as well as phase angle, and there will be sinusoidal waveform. The DC will not have any sinusoidal waveform in there. So energy stored in the capacitor is half CV square, and energy stored in the inductor is half Li square. Okay, in DC, so we're talking about steady state. In steady state, inductor acts like a L is nothing but inductor acts like a short circuit, and capacitor in steady state, capacitor acts like a open circuit. So here my circuit is going to be look like this. I'm going to redraw the circuit. 45 volt, 9 ohm. So here is the final circuit. So inductor is going to act like a short circuit and capacitor is going to act like an open circuit. So to find VC, it's a simple, since there are two sources, I'm going to use the nodal analysis to find the voltage VC. So here I know the voltage here is 0 volt, so the voltage here must be 45 volt, the voltage here must be 30 volt. So what is VC? VC must be 45 minus 30, which is 15 volts. That's so simple. So energy stored in the capacitor is half CV square, half times 0.5 times 15 square. Okay, now we'll find IL. So to find IL, I'm going to use the nodal analysis. What is the voltage at this point? At that point, the voltage must be 0 because it's a short circuit. And I'm going to take this voltage as V1. At V1, apply KCL. So if I apply KCL here, I'm going to take every current is going out, I1, I2, I3. So I1 plus I2 plus I3 equal to 0. What is I1? I1 is nothing but V1 minus 45 divided by 9 plus I2 V1 over 6, I3 V1 minus 0 over 3 equal to 0. To eliminate the denominator, I'm going to multiply this with 18. So 2V1 minus 90 plus 3V1 plus 6V1 equal to 0. So I have 11V1 equal to 90, V1 equal to 90 divided by 11. This value equal to 8.18 volt. So once I have V1, my goal is finding IL anyway. So I know the voltage here is 8.18 volt. That's 0 volts. That's 30 volt. Let me change. So can we find this current I3, and I'm going to find I4. Can I say IL is same as I3 plus I4? I3 equal to 8.18 minus 0 over 3, and I4 equal to 30 minus 0 over 4. IL equal to sum of those two. So I3 equal to 2.727 ampere and I4 equal to 7.5 amperes. Total current is IL equal to I3 plus I4, which is 7.5 plus 2.727. That value equal to 10.227 ampere. Okay, so what is the energy stored in the inductor? Half Li square. So half time L is 2, I square is 10.227 whole square, whatever that value is. That value is whole square, which is 104.59 joule. How about the one here? This value must be 225 divided by 4, 56.25 joules. That's the energy stored in the capacitor. This is energy stored in the inductor. Okay, thank you.